All right, in this video, we will continue solving right triangles. So I've changed a few things in my notes to better represent what we're doing. So I've drawn the pictures a little ahead of time, so it'll be a little bit smoother than the last video, since we know now how the angles and the form triangles. So in the last video, all of ours was done on the x and y coordinate system by taking two rays and grouping them together. In this, we're going to just create right triangles. And this allows us to draw them of any shape, any size, any orientation. We don't have to worry so much about where x and y are. So, a couple of refreshers. What is a right triangle? Right, so it is a shape that has three sides, where one of the angles forms a 90-degree angle, and then all three angles add up to 180 degrees. And now we're going to label our triangle a little bit different than we did last time, since we're not on the XY plane. We're going to label our angles A, B, and C, capital letters. So capital A, capital B, and capital C are my angles. Little a, little b, little c are my sides. Angle C is typically the 90-degree angle, and angles A and B are acute angles because they sum to 90, and this means they are complementary angles. Right, because if C is 90, then the other two also have to be 90, because 90 plus 90 is 180. Notice the side A, little a, is across from angle A. So if angle A is in the bottom left, side A is directly across from it. Angle B is in the top, side B is in the bottom. Angle C is typically always the 90-degree angle, and side C is the hypotenuse, but again, it's across from it. This just is done for simplicity. You do not have to do it this way, but I recommend you do it because it will make learning this a lot easier, because these are just variables and you can pick any letters that you like. But what does help is by having the sides across from each other, we will change how we find our ratios of our trigonometric functions, as well as now we have A, B, and C, which falls in line with what we've seen before in the Pythagorean Theorem, a squared plus b squared equals c squared. So from last class, we learned sine, cosine, tangent, cosecant, secant, and cotangent, right? And we had y's and x's and r's. Well, now I'm going to change it to where we have opposite over hypotenuse. So I still have theta for now, but you can put in a. So if I put in sine a, opposite over hypotenuse means it will be little a over low c. While cosine of angle A will be adjacent, which is the side next to it, and which would be B, and my hypotenuse is C. C is next to it, but we know C is the hypotenuse, so we're going to leave C as not the adjacent. And tangent of A would be opposite A over adjacent B. But what allows me, so I don't always have to stay in A, I can come up here into B, right? So the sine of B is little b opposite over hypotenuse, so it's b over c. So we have this little functionality here. I'm trying to see if I can make this a little bit bigger so we can see it. That these are equal, so the sine of A equals the cosine of B. Because remember, sine of A was A over C, and cosine of B is adjacent, which is A over C. So this allows you to move things around very quickly. It also falls in line with, if you've heard the acronym before, SOHCAHTOA, right? And SOHCAHTOA is sine opposite, sine opposite over hypotenuse, SOHCAHTOA, cosine adjacent hypotenuse, and then TOA, tangent opposite adjacent. And if we want to do our inverse functions, then everything just flips. So we kind of talked a lot about those last video. So how this helps us solving our triangle? So if we always set up our triangle to be ABC, where C is the 90, A and B are capital A and B are our angles, and then our sides are opposite of our angles, I can follow these procedures. So sketch our right triangle and label the knowns and the unknowns. Express the unknowns in terms of the knowns, and check your results. right? When you're finished, your angle should sum to 180, and the Pythagorean theorem is true. So to solve a right triangle, you need to have two pieces of information. So we're going to do two different triangles. First, we're going to do one where this is what we know, right? This is everything we know right here. And I'll highlight what we know in yellow. So this is what we know. We know it's a right triangle, obviously. We know angle A is 55 and side B is 5.5. So remember, angle A was here. That means angle B is up top, and then side B is across from angle B. So that's the information I know. So instead of putting A and B out, I put 55 and 5.5. And then I label everything I don't know. I still put a C here just so that we remember that angle C is the 90. So what do we have to find? We need to find little a, we need to find little c, and we need to find angle B. Well, the good news is we know that A and B added together must equal 90. So if I take 90 and minus the 55 from angle A, I get 35. So we know then angle B must equal 35. Because 35 plus 55 is 90 plus 90. So there is my 180. So my angles are done. Now, a lot of you will try to use the Pythagorean theorem, but I can only use the Pythagorean theorem if I know two sides. And in this case, I only knew one. So what I need to do is use my trig functions. So I like tangent for no other reason. I just do. So you may pick any one you want. But because I know the adjacent side, and I know this is 55, then I should pick something up here that has adjacent in it. So I can do tangent, or I can do cosine, if I'm at angle A, right? So I chose tangent. So tangent of 55 degrees equals opposite, which is A, over adjacent, which is 5.5. So now I do some algebra, right? I multiply both sides by 5.5 to get this to kind of solve. I'll draw it out so you can kind of see it real quick here over on the side. So if the tangent of 55, let me scroll over, view, hide my navigation panel so I give some more room to work here. Okay, tangent of 55 equals A over 5.5. So if I multiply both sides by 5.5, then these two 5.5s cancel. So A equals 5.5 times the tangent of 55. So then I just go to my calculator and I type tangent of 55 times 5.5. So I get the answer 7.85. Right? So now I know little a equals 7.85. And since my answer was rounded to one decimal, I'll probably keep it the same, so we'll call this 7.9. And then to find C, now if you want to, you can use the Pythagorean theorem, right? But I am going to use trig function again so we can see how it works. So now if I do, I'll even use the opposite angle. So if I do the sine of 35, and that equals, sine is opposite, right? So that's 5.5. Sorry, my pen stopped working here. Over my hypotenuse, which is C. So now I got to solve for C. So the first thing I'm going to do is multiply both sides by C, right? And then those C's cancel. And then to get my tangent to the other side, I mean not my tangent, my sine, then I will divide sine of 35 by both sides. So therefore, clean this up a little bit. Those cancel. So C equals 5.5 divided by the sine of 35. So, in your calculator, I do 5.5 divided by sine of 35, and I get 9.59, which means C equals 9.6. And again, there's lots of ways you could have solved this, but that's what I've listed here. So clean up my area a little bit so we can continue on some of these problems. So and the next example we'll have, right? So here's another example with, again, I'll highlight in yellow what we know. So example, we know it's a right triangle. We now know side A is 15 and side B is 12. So in this case, we know both sides, right? So now I can use Pythagorean Theorem, right? A squared, 12 squared, plus B squared, I'm sorry, A squared, 15 squared, plus B squared, 12 squared. So if 12 squared plus 15 squared equals 369, and then we take the square root of 369 and we get 19.21. So C equals, again, since these are whole numbers, we'll round to the nearest whole number, so 19 equals C. All right, and now I got to find one of the angles. Well, again, I stick with tangent, and I'm going to do A. So the tangent of A is opposite, 15 over adjacent, which is 12. So I put 15 over 12. And now, because I am looking for an angle, I use the -1 key on my calculator. So I do tangent -1 of 15 over 12, and I get 51.34 degrees. So we know angle A is 15.34. And now I use the 90 trick. 90 minus 51.34 equals 38.6, which equals angle B. So we have now solved a triangle where we knew an angle and a side. We solved a triangle where we knew two sides. So those are the two types of right triangles we will be solving in our class. And then we could do a word problem. So this is one I like to do in class. And we'd have some huge assumptions here because we are doing a right triangle. But say we're kicking a field goal from the 50-yard line. And we have to assume that the football travels in a straight line, which anyone who watches football knows it does not, but we're going to stick because we're doing right triangles. When you take pre-calc, then you can get into the fun analysis when it doesn't follow a straight line. But for us, we're going to stick with the straight line. What is the angle of the kick in the distance the ball travels? Well, if you know about football, it's a 50-yard. If the football's on the 50-yard line, that's 50 yards to the end zone, plus the end zone is 10 more yards. So the football from the ground to the field goal post is 60 yards. And then the field goal post is 10 feet. So I got to keep my things the same. So 10 feet is approximately 3 1/3 yards. So I've changed my whole problem to be yards. And now I draw my little right triangle. Again, because everything has to be a right triangle. So when you're doing the word problems for this section, realize that everything has to be a right triangle. So somehow you have to create a right triangle. So to find A, again, I like my tangent. So A's down here where the kicker is. So opposite is 3 1/3. And 60 is my adjacent. So just on my calculator, tangent -1 of 3 1/3 and over 60 gives me an angle of kick of 3.18 degrees. And then I can use Pythagorean Theorem to find how far the ball travels. And you can see it's not much further. It's only 0.1 more of a yard, and that's because the angle of kick is so low. But basically, when you're solving word problems for right angle trig, always find a way to draw a right triangle, label, and then you're back to either knowing two sides or an angle and a side. So hopefully this video helps finish out trigonometry in chapter 4. First video kind of goes into the whys and why we do what we're doing. And in this video is kind of the applications. So if you have any questions, please comment on the video or reach out to me. Thank you.